Thank you for inviting me this evening. And so I will share my presentation. All right, so I will talk about language models, and especially in a way that, yes, they're better, but are they really worth it? And so I will base, this speech is mainly based on one paper, which is called Danger of Stochastic Parrots, Can Language Models Be Too Big? By Bender, Gebru, Macmillan Major, and Schmittel. So first of all, I will speak, I will speak about what is a language model for those who don't know. So the definition is basically a system that trains on string prediction task. So the easiest way to see it is that you take a sentence and you hide a word. And the goal of this model is to learn which word was hidden. Very simple in terms of data, very simple to have it. You just need text. You don't need any annotation, so it's very easy to train. And this model has been there for a long time, and you may have heard some of them, like Word2Vec, Glove, Context2Vec, or Elmo, which are historical models that were there before the well-known model of transformers. And so since last year, we have... Okay, so if you could... Thanks. We have saw some new challenges in the language models environment, which are there. So the first one is BERT, with only 340 million parameters, and that has been trained as 16 gigabytes of text, which is in number of books, if you prepare an easier comparison, 60,000 books. So it was the first one to come, and he has just beaten everybody on every task. And afterwards, some other papers came out with other models, even bigger, like Megatron-M, with 8 billion parameters and 10 times more data for training. Then you had the GPT-3 with 175 billion parameters. And the last one is Switch C by Google with 1.6 trillion parameters, which are really huge models. If you compare to the models you use, they are really incredibly huge. And they have created a new paradigm, which is you will take a pre-trained model like BERT or GPT-3, and you will fine-tune it on your task. And this has led to new state-of-the-art on practically every task. So, for example, if we look at here, so my text is not at the right place, but okay. So GLUE has been a benchmark trying to see if models could, if some ALM models could beat humans on tasks that require text comprehension. And what we can see here is that now we have at least 14 models that are better than humans on this task. So after that, they say, okay, maybe our tasks are a bit too easy. We will try to use some other tasks. And last year, they have published a new task, which is called SuperGLUE. And even then now, we have models that are even better than human on this task, which are supposed to represent models that understand language. So it's pretty great. Like it's even better than human. So why are some people complaining about it? After all, it's a goal of a long time to understand language, and now we are models that are close to it, or seems to at least. So why some people are saying it's not a good thing? So the first point is the training cost. As you can imagine, this model requires a huge computing power to be trained. A paper published in 2019 look at that and try to make some estimation of the environmental environmental cost of training such models. And so they found that for training birds, it was roughly equivalent to a trans-American flight. And that's BERT, which is not the biggest model we have now, and a lot of them have been trained. And that's only the training part. Each time you use it, you use energy, and you have to add it to the costs. And if you use it a lot, inference costs will be much higher than training costs. So it's kind of polluting. The other part is the financial costs. First of all, energy is not free. And so huge usage of energy means huge usage of money and expenses. And the same paper estimated that if you wanted to train birds on a cloud computing platform, it will cost between $4,000 and $12,000 to train one model. And when you make experiments, you don't only train one model because you have several hyperparameters, you want to fine-tune them, you want to do a lot of different tasks on them. So it will cost much more. And that's only for BERT, which is not the biggest, and that doesn't use some fancy things like neural architecture search, where you try to learn even the structure of your model. And for a company, the inference costs can easily beat the training cost. It will cost much higher in inference than in training. So you have to take it into account. And if you think about that, it also led to some more ethical issues. First of all, not everybody can use this model because in research, you want to be able to reproduce a model. And not a lot of labs can spend $10,000 to reproduce a model to verify if it's currently good or not. So it's pretty hard to see that, and only some big companies or big labs can do it. As I said before, it's also a negative environmental impact because it's very demanding in energy. And one thing that says the paper, it's that the risk-benefit ratio are not well distributed because if you think at who will be impacted by climate change and who will benefit from these models, it's not the same population. The first communities that will be impacted by climate change are not communities that will be using this model in a way or another. Generally, this model will be used in things like Alexa or this vocal assistant that are not going to be used by people living in Somalia or on some Atlantic islands. And that's an issue because these models are perpetuating in some way a risk between communities. So the one benefiting from this model are not, in fact, impacted by the risk it creates. So that's kind of an issue. The second part that you can look at, it's uncurated data sets. Because this data comes from web crawling. And I see that you know that the web, you have everything on it. And you can find good things and bad things. And when you have this quantity of data, you can't verify them by hand. And what we know furthermore is that when you look at who is contributing to the internet, even if it's worldwide, most of the contributors come from Europe, USA, China, and so it's not evenly distributed between communities. And especially marginalized populations will avoid mainstream sites, which are the ones that will be taken from web crawling, not some sites that nobody is using, that not a lot of people are using. And so that's an issue because the viewpoint that is mainly represented in this data are hegemonic viewpoints. So like white supremacists, like misogynistic point of view, all the kind of things are overrepresented even when you compare to the general population. For example, one part that has been used in GPT-3 was Reddit. I believe you all know Reddit, and some searcher found that some data that was taken to train this model came from banned Reddit because of what was inside this Reddit. So it's kind of an issue because this data is not representative. So you can't say that you have a model that is representative of language if your data doesn't represent that. So that's an issue. The second point that they found, that has been found, is that models are even more biased than the data. It's something that is well known because generally that's what you want. You want your model to encode bias because it will be easier to find the right class or the right label for your task. But when it comes from bias like gender bias or racist bias, it's an issue. And so some examples that have been found in some of these models is that BERT tends to associate disabled persons with more negative sentiment words than not disabled persons. And GPT-3 can generate toxic texts even when you prompt non-toxic text. So GPT-3 asks you to write some text and will then generate text for you, given what you've written beforehand. And it can generate things that are toxic, even when what you say wasn't. So it shows that GPT-3 has some kind of bias that will generate toxic text. And when we speak about bias, one of the issues is how you can see it's a bias, because we all have our biases. We know that. And so one of the points that he said in this paper is that we need to work with marginalized population to audit for bias, because we are not really able to do it if we are only us. And it's impossible to do it for hundreds of gigabytes of text, which is a huge issue. So one thing they say is that feeding AI systems on the world's beauty, ugliness, and cruelty, but expecting it to reflect only the beauty is a fantasy, which means that you can't say that your model is perfect because your data isn't. You have bias in your data, so you can say you have a model that represents the world because there is bias in your data, as there is bias in the model at the end. It has to be, it's like that. So what they say is that language models are kind of the easy path because they are currently on top of all the leaderboards of practically all the tasks you can think of in NLP. And so people are saying that they will lead us to natural language understanding. But at the same time, the issue that it overshadows other research, which are trying to work on small data sets which are carefully curated to not contain any biases. And today, it's far easier to publish a paper when you are state-of-the-art than to publish a paper saying, I'm not state-of-the-art, but I've done that. I've worked on things that it won't injure any population it could. It doesn't really care today on the world of publication. So it's a big issue. And also, what they say is that language is pairing forms and meaning. And language models only have access to form, because when you speak to someone, you can say the same sentence to two people, and they will take it differently. Because maybe you know them, you know which bias they have, which idea they can extract from what you said. And so language is meaning between two persons, because we know the other person, or we think we know it, or we make assumption on the other person when we talk, and we will choose a reward for that. But these language models, they don't do that. They just generate text. And so it's very different in the way people are really talking. So we can't really speak about natural language understanding. And that's a big issue because a lot of people now are blinded with that, saying we will be able to solve natural language understanding, which is in fact not possible with kind of models. So it's a big issue. But they also point to things we can do to improve the research. And a citation of the paper is, "We should consider our research time and effort a valuable resource to be spent to the extent possible on research projects that build towards a technological ecosystem whose benefits are at least evenly distributed or better accrue to those historically most marginalized." Because nowadays, when we build a model, generally, the people we will enjoy the benefit of these models will be people in position of power. And so this model will tend to marginalize even more marginalized population. And that's a big issue on how we see it. And so what we can do in some ways which are easier to see, it's from now on, stop trying to make bigger models because it's not really interesting, but working more on trying to understand how the models are doing what they do. Because models like BERT are like for no big black box. Some researchers are working on what is happening inside, but in fact, we don't know that much. And there is no meaning anymore of linguistics in this model. It's just, like architecture, people coming from deep learning, doing big architecture, saying it works, we have a better score on this data set, on this task, so it's better. But you can't skip linguistic from in NLP, and that's kind of an issue. So we need to focus more on trying to understand before trying to do bigger models, because if we don't understand like the smallest model with this kind of architecture, how can we understand what the bigger will do? And we can't improve it if we don't understand them. Second point, they point to several frameworks to describe the uses of your models, saying this model has to be used for this specific task on this population with these assumptions, so that sometimes models are just misused, and you want to avoid that. You also have to identify who will be impacted directly and indirectly by your model and work with them. Because sometimes, as a researcher, as a developer, it's hard to really see the impact of your work on people. And so asking the people that will be impacted will help you doing better models that will be less able to injure some populations. And the last point is, instead of thinking about metric improvement, look at the trade-off between energy consumption and metric improvement. Strobel has shown a paper and trying to see how much costs an improvement point compared to the model they've made in the paper and the precedent state of the art. And they found it was costing around $150,000 for 0.1 points of blue metric. So it's a metric on 100. So it's really huge. It's not a huge improvement of 0.5. It's a small improvement, and it was costing $150,000. So sometimes you have to think more about, okay, this model is a bit better, but it will cost 10 times, 20 times, 30 times more. Is it really worth it for my application? And thinking about that could make us make better choices in terms of models, because we have to take into account metric of energy consumption in our models now, and not just the best model with the metric you want. And it's a trade-off you have to think about. And so that's all for me. If you have any question, I will be happy to answer them.